We will have time for you to go further than that, Tim.
That's correct.
Fred,
That's correct.
yeah.
Okay,
Yeah.
very good. So one of the things in this world of using chemicals is the small, as we said here, small changes make big differences. And a lot of these are ideas that as we go through this talk, they're ideas that people either don't know or are confused or don't consider until after the fact. So we're going to go through basically these particular topics. And so for anybody out there who has an interest that wants more information on any of these subjects that we call, all you have to do is send me an email at Whitford at Purdue, and I'll send you a copy of the publication, and or maybe we can make it available online. So do not assume that whoever you're talking to, no matter how successful he or she is, that these basic facts are known. And I can tell you through my 30 years here at Purdue, a lot of this stuff is not known or has been forgotten. So I will ask you right off the bat here, Tony, do you know what is there a difference between a fluid ounce and a dry ounce, Tony?
Yes, Fred, I've heard you speak a couple of times. I know that there are differences.
That doesn't mean you remembered anything.
That's true.
So what is the difference? Do you remember?
You might use a different measuring cup is one thing.
So you're hitting all around it. So a fluid ounce, if you think about it, it's what 28 ounces to the gallon, and a dry ounce is 16 ounces to a pound. They're completely different units. This fluid is volume, and the dry is based on weight. Now, I'm just going to show you these graphics, and I'm telling you, this is one that over and over I see again, especially as we become younger. So these are one of these facts that sort of stopped somewhere during the generations, but young people specifically have forgotten this or didn't learn it. So I took 3 ounces of salt, and you can see here fluid ounces. I used a measuring cup. And then I took 3 ounces and I weighed it. Can you see the difference in the same bottle? So obviously, if you screw this up and you mismeasure, specifically if you mismeasure dry ounces, and a lot of people do it, they put in liquid measuring cups. Sometimes the difference is a lot. And especially with the chemistry being the way it is, as Bill talked about yesterday, the shortage and the not wanting to waste product. So you don't measure dry materials in liquid measuring cups. That's the key. And now this is one of the first questions that I ask when we have failures. Now, Bill didn't really address it yesterday, though I would assume, Bill, that you would agree that there is really the possibility that growers are going to cut rates to save money, just like we're doing on fertilizers, like everything else. Do you think that that's a possibility?
Oh, absolutely. Whenever commodity prices are low, that's one of the first things that gets cut is either the questions come in about what active ingredient can I leave out, or how much do I really need to apply?
Yes.
So absolutely.
So even though cereal rye and a lot of these cover crops are relatively easy to kill at full rates at the right timing, if I start cutting rates, does that begin to potentially affect my kill?
Oh, yes, and what I like to talk about herbicide variability. Yes, absolutely. Herbicide variability can be related to whenever you're spraying during weather conditions that are on the fringe, or whenever sprayer setup is on the fringe, meaning it's not at the optimal timing. And that's in combining reduced herbicide rates with spraying under non-optimal conditions results in failure more often than not.
Okay. Now, a lot of this talk is, if you think of just what Bill just said, a lot of this talk is not getting the right rates or cutting the rates thinking you've got that, but you don't. And I'll show you what we're talking about. So this is a liquid, dry tube, 15 ounces. The one that I went on was using 15 ounces of fluid ounce. You can see these tubes are about the same. And he said 15 ounces is 15 ounces. Well, it is 15 ounces, it's 15 ounces. But when you're looking at this difference, you need this much and you're way down the here, folks, that makes a world. You've diluted your tank. Now, if you went the other way and you use that, you have now spent a small fortune compared to the prices. But I'm more worried about people not knowing this difference and measuring. And so this is an example here. You don't have to even know what this product is, but anytime I have a dry product and I use a liquid measuring cup, I'm screwed. It's the first question I ask now. I go to that because when you're trying to answer people's questions, I'm going to start out with the most basic. All right. So, Stephanie, what weighs more, a pound of feathers or a pound of lead?
Definitely the lead.
You sure?
I think yes. Well, wait, hold on a second. I hate those trick questions.
Thinking.
It weighs the same. I got to stop overthinking.
Now, a pound of feathers, as the other person, 15 ounces is 15 ounces. A pound of feathers and a pound of lead are the same. But what's the difference? When you weigh the stuff out, Stephanie, what are you going to know about your piles?
The lead pile is going to be really small, and with the feathers, I'm probably going to be able to make a feather blanket or feather pillow.
That's right. Which is why when you buy a box of cereal, you open it up or chips and you say, where's the rest of it? Because in your mind, you're looking at volume. They're selling it to you by weight. All right. Now, let me see what's happening here. Something, but let's go here. So my point here is this. If I take creamer, grits, sugar, and salts, and I weigh them out, 3 ounces. They're all 3 ounces. A pound is a pound. But when you look at how much is in each one of these jars, you notice I got a lot more coffee creamer because it's much lighter. All right. Now, if you looked at these tubes, the numbers on the tubes, on these dry tubes, are specific for that product. You don't interchange the tubes. And so if you didn't know it and you interchange the tubes, now you begin to get problems, specifically if you underdose. I can always say if I'll get good kill, but I'm spending a lot of money. I'm going to put that to the side. Nobody's going to call you on that. What they're going to call you on is if something didn't work. And so the second question, how did you weigh it? And what product did you use? And let me see what tubes you used. Now, these tubes, right off the bat, this is about as accurate as you're going to get on any of these dry tubes. And I've never asked this to Bill. I've always said you didn't, but I'll ask you now. Bill, when you do your research, do you use these dry tubes? Do you weigh things?
Well, with really low volumes that we mix up in 2-liter bottles, many times we'll weigh it. So we'll figure out what the specific density of the liquid is and weigh it.
Yes. Now, nobody in the real world is going to do that.
Right.
All right. But what I want you to see is 7.5% off, plus or minus. Now, in my world, that's 15%. I can go 7.5 up, 7.5 down. Now, folks, if you think about cutting rates, and I've got this error, I could be cutting rates and then still be another 7.5% off. They can't make it any better. And the reason is, how are they trying to gauge this? Like a measuring cup, a liquid measuring cup. And all of you know that the weight of a product depends on the size of the granules, the dry material. Some are busted, and I'll show you that just in a second. Plus or minus 10%. By the way, I've never found one that's any better than that. Plus or minus 10%. People will tell you, I want it to be accurate. No, you don't. You want to be able to pour a dry material like you do a liquid. And that's why these manufacturers will tell you that. Here is one that's plus or minus 15%. Now, what I want you to see is what they're telling you right here. They would like to see you weigh this stuff out. And this is one of my favorites, plus or minus 20%. Bill, I can eyeball this better than that, couldn't you? I could do, I mean, it's pretty amazing. So as you start looking at people, I start looking at failures, let's say, look at if they're using any dry materials. And again, this is Bill's world. But if they're using any dry materials, look at what their rates are, and then look at this plus or minus, specifically the minus. What I would love to see, just to show you as an option, this happens to be a lawn care, golf courses. A handful of farmers are actually doing this. You get a scale, you zero out the cup. They got to know to zero out the cup. And then if I wanted a product, I can weigh the product. And that way, I don't have a plus or minus. I've done this at field days, and it's just amazing that plus or minus, how it shows up. And you can see here with these granular materials, you'll see big pieces, little pieces, fine pieces, and how much volume it takes to get that weight then depends on those pieces. If you're looking at failures, Hans, are you there?
Yes, sir.
So Hans, I mean, you've been out there. So tell me, I've got a failure. Oh, sorry. How can I have 3-gallon mark, 2 different 3-gallon marks? And actually, Stephanie, where did you get your what do you call it? Your laser pointer?
So I'm looking at your screen. If you go towards the bottom, there should be a, maybe those 3 dots. Do you see those 3 dots there? What is it? If you click on them, what does it show when you click on those 3 dots?
Screen, use presenter, nothing. Let me do the little square. Oh, here it is.
Okay.
Yeah, there we go. So it's the little square. So Hans, I've got 3 gallons there and there. Any idea why I would have 2 3-gallon marks?
Oh yeah, different products.
Nope.
If I'm using multiple products in the same tank,
Nope.
then or you know,
Ask the little fella Ask the little fella who's sitting there with you. I bet he can answer better than that, Hans.
oh, you think that's that bad?
Oh, I think it's that bad.
Oh man, goodness,
Right?
you caught me then.
So look at this, and people don't realize these are international products. This is imperial gallons, and this is U.S. gallons. And so the guy that sent me this one was doing brush control, which is about as hard, Bill, to kill when we start trying to kill brush, not for this year to brown it, to kill it, but to have it killed for the springtime. So he used the 3. He didn't want to, he just filled it up more. And what he did was he diluted his tank. U.S. gallons would have been down here, and that was enough then to dilute his tank. And all of this is reducing your rates. Another one, if you're looking at just some general things, has to do with the tanks. You'll ask people what tanks they have. They know the size. And they know the size because it's what it says on the outside. These are 2 real examples that now I know to ask. Again, it's a series of questions in your world. As Adam and Hans were talking yesterday, right, Stephanie, and you were doing today, there's a series of questions to ask. These are some of the questions that I asked. And so how do you know it's 1,000 gallons? Well, because it says. All right. So when this example, when they actually measured, it was 950. The 750 was the one that was of concern. It was 875 gallons of water. So, and Bill, I can't do the math real quick, but let's do the bottom. If let's say what 20 goes into that, what is that, Bill? If I'm doing 20 gallons of water, that's 30, 40. Let's just say 40. That's close enough, right? Would 40 work? Yeah, yes. 40. Yep. So if I that would be 40 acres. If you told me 2 ounces, that would be 80 ounces. But actually, look how much more water I got. I can do a number more acres based on this tank being mismarked. And so again, it's this already cutting rates, and now I'm cutting it right here. I've had a number every year where people are using these marks to guide them. So if you looked at the marks here, obviously, in order for the marks to be evenly spaced, doesn't the tank have to be straight? So what you want to see when you look at the butt end of a tank is to look at the marks. And the marks down, let's go to the top here. You look at this top area. I should have less water, so it means my marks are a lot bigger. But as I get down into the middle part of the tank, do you notice that that 50-gallon mark gets smaller? Well, that's because I've got more water in that middle. I have had tanks that are evenly spaced like this, and it's impossible. It can't be. I've only asked one manufacturer, said, why are you doing that? And they gave me because it looks better. That was their answer. It looks better. So again, you're trying to figure out why things failed. And so we looked at, do they understand the difference in fluid and dry? Do they understand that that these tubes are plus or minus? Are their tanks actually measured correctly? And by the way, it's easy to do. You just take your tanks over the scales when they're empty, you weigh it, fill it up the next time you're there at the ag retail at your place, weigh it when it's full. If it's 1,000-gallon tank times what is it, 8.345, it gives you an idea very quickly, or you use a flow meter. Now, one of the things that I've worked on the last few years has been how long do these chemicals last? And what I've just recently learned that these products basically have a expiration date of 3 years. That you can depend on 3 years. And we do whole talks on this. And after the 3 years, bad things could begin to start. This would be an explanation for possible failures if a product is old. Or this, if you look at the products they're using, and you can see here, if you're in a barn and you see and you're reading off these labels and the products have not been stored properly, then that means that that chemical more than likely has the potential to not be at that full strength. That's what it means. And that's why these manufacturers on some of Bill's products can't fix this. This is inherent. And so they depend on us to do it. A simple tool is just one of the things we could do is put a purchase date on it.
Easiest things to make sure that we stay within that 2 or 3 year limit. And again, we could say 3 year limit for an expiration would be to actually do what they're doing here, which is to label their different products with the year that it was purchased. So I now know that these were purchased in 2020. And so that I know that I've got a couple of years that I really want to make sure that I get this put in. Here is another product that was purchased in 2019. And this tells me then that this product now has got what? The 2019 season, probably the 2020 season. I am starting to get close on.
So that gives you, just think of the age and use 3 years. It could be longer, but we don't know that. We would have to ask the manufacturer, and nobody's going to do that. But so if it's an older product. Now, let's go to the second, which incompatibility, that these products are incompatible. It's a big issue. Bill, you've done plenty of research on it now. You're wheat scientist people. If there's ever a question of if something is incompatible, Bill, we're seeing something didn't work, this incompatibility could be part of that reason. Is that right?
Yes, that's
Okay.
correct.
Now, I'm going to get that for many of them, it's going to be on the label, correct?
That's
and
correct.
it's going to
Yep.
tell me don't mix with this, that, or that others. And then others we don't know about because it's still being researched as people try to combine this mass of products in a tank. Folks, to start with, our growers, I understand why you want to tank mix as much as you can to make fewer passes. With the price of fuel going up, and up, first of all, I expect to see more. I'm going to go back to many years back. I expect to see a lot more fuel being stolen off farm, diesel fuel like we saw before. And so everybody wants to make less trips to save money. I understand that. When we talk about these ingredients, and Bill, you mentioned a bunch of them yesterday out of the wheat guide. You mentioned them by trade name, which is what everybody talks about. I mean, well, you mentioned a lot of chemical names and also trade names. Gets confusing. I'm going to make it even more confusing that these products may have dozens of chemistries in them. There's the active, and it's all these things that you and I call inerts that people just view like hot dogs. It's just it's just a filler. These inerts are extremely important. That's what makes these products work, folks. Now I have not given them as much credit in the past as I do now. There's two kinds of incompatibility. One you can see, one you can't. So the first one is the chemical. Now let me show you here what that means, and I've got one of Bill's slides in here. So chemical incompatibility is when you mix the products and they look pretty good. They work fine. I mean, I look in the tank, everything mixes up, it's the right color, no problem. But when I apply in, something happens. So this is not one of yours in the ag side, but it doesn't make any difference. So a claim plus a 9-ounce surfactant does a really good job on crabgrass. You can see here to here. But when I add Trimec, which is a broadleaf, wants to kill broadleaf, I add that to a claim. Look at all the crabgrass. So, Bill, I mean, this is not one of your products, but it's the same concept, right? What could have happened here?
Well, and it's a very common thing that we see on the agricultural side of things as well, is that the growth regulator herbicides, which are in a claim is 2,4-D, dicamba, and MCPP, so 3 growth regulator herbicides. When you mix those with a grass herbicide, you see less grass and less grass activity, less grass control from your grass herbicide.
Okay, so right there, I'm going to assume I should have checked it that's on the label. That would be one of the things that's going to tell you not to mix with. Or
it'll say increase the rate of the grass herbicide, or it may give some specific adjuvant recommendations.
Okay, so sometimes we can make that up by making the products hotter by adding an adjuvant. We'll talk about that in a second. So, Bill, this is one of your slides. Notice I didn't put in the data slide. This is one of your slides. And so tell me what's happening here. Do you remember this one?
Yes. Yep. So we're not getting effective control of volunteer corn. Volunteer corn is normally a weed that's easy to kill with the group 1 herbicides, the clethodims and the quizalofops, the select and assures. And what's happening now is we know there are 2 active ingredients that antagonize clethodim or quizalofop. And those are the warrant type herbicides that are formulated as a soluble concentrate, and the growth regulator herbicides like 2,4-D and dicamba can antagonize those grass herbicides as well. So as a result, your volunteer corn control is not good with the grass herbicide.
So when somebody says the corn's resistant, it's resistant that the corn's not going to the corn's not resistant. Your chemicals just didn't work.
That's correct. And if we compare the our ability to control volunteer corn now with, say, 10 to 15 years ago. 10 to 15 years ago, all we were doing is adding the grass herbicide to our glyphosate. All right. Now, when we go across that field, we might have glyphosate, 2,4-D or dicamba, warrant, foliar fertilizer, and maybe an insecticide in a soybean treatment as well. So we've got way too many things in the tank. We don't understand the interactions between all of them.
So if we had a failure, if the failure to kill, we talked about that easy stuff. Now we're going to look at the products they're using. Did it fail because I mixed a number of products together that didn't work? Now this is the one that's easy to tell. I think I'd rather have the other one, but this is the one. This is what happens when you mix products. Looks like a milkshake, looks like latex paint. Isn't that cool? That's a great picture there. I think the guy needs a new pair of gloves, but that's a whole nother talk. So here are some conditions that we're going to look at to make sure that these products are going to work. All of you know that if you like oil and salad dressing, which I don't, but some of you do, you are not going to, that's what this is. You're not going to just pour that onto your salad. You're going to shake it up to make sure you get a good blend of everything. And folks, our chemistries are no different than this. So if you are taking products off the shelves, and again, these are questions you can ask when you're there of why something didn't work. So if you see layering out in the jugs, and I need the actives and the inerts mixed together, if they're separated like that, the product is not going to have a chance to work as well.
The tank.
This is what they do in the big tanks at the ag retailers.
So
They're going to circulate the tank to make sure the actives and the inerts are mixed. And you're seeing that right here. So basically, if you're looking at, especially if the product says shake well, you can ask that question because there's a reason that the manufacturer puts that on, and I want to see that active and the inert mixed up. I always blew that off thinking, yeah, whatever. But as it turns out, it's pretty important. And in fact, I saw this particular product. I couldn't see anything, but I noticed it said shake well before using. So it implies that I can't always see it, but I know that if I see this, I need to do it. There's a reason it's on that jug. And this includes the mini bulks. When you're looking at the mini bulks, they too separate. It's just another container. We have a problem there. And the problem is if the farmer has that sitting, he's not supposed to open these up. Now, I know that they do. And I know that I should say, since we're being recorded, I know that some do. And I know that some retailers don't have a problem with it, but I also know some do. It makes it pretty difficult if without cutting that to be able to stir that up with the paint stir or whatever. But or basically putting it on a forklift and trying to shake it. But this is part of it. When you're out there, you can see this. Now look at this one. All of you know that the less water that I use, and especially on some of these small contraptions, look at the difference when I am mixing products when I don't use enough water. And this is the scum and the crud that we don't want to see. And let me show you this example here, why that's important. Let's see if I can, let me see if I can make this one work. There we go. Now I can't see. Where is the, so, well, it's not, apparently it's not going to work here for whatever reason. I don't see my little bar to make it move. So, nope. So let's just move on. Basically what it shows is I could take sugar, put it in a little glass and it dissolves. But I put a whole lot of sugar in, it can't dissolve. and never will dissolve. Water can only hold so much material. The less water I use, and this is an example of your glyphosate and 2,4-D that this guy sent me, when you don't use at least 50% water, this has the possibility. And so, Bill, this is an example of two particular products with other inerts. It doesn't have to be the actives, with other inerts that when you have a lot less water, things are too close together and that I guess have a chance to react. Is that correct?
Yes. Yep.
Now, this is another one that causes this problem. Because if I don't get things mixed up right, then what comes out of the nozzle? I mean, ultimately, that's what counts. The rest of the stuff doesn't make a difference if I can get it out. So using liquid fertilizer, what time is it? Yep. Using liquid fertilizer. And I would ask some of you, why can't I get more than 32%? If I could get more, it'd be better. Because water can only hold. That's all that water can hold. So if you come in with a dry material that needs lots of water to dissolve and you put it into fertilizer, it floats. It floats. So I'll show you this one here, what it looks like. And folks, I don't know about you, I would hate to spend my day cleaning out cow guts out of this thing. This guy here, I don't know. Stephanie, do you know why?
I'm not sure, Fred. I was going to see if Lisa had any thoughts on.
Oh, I did something. Let's see. Yeah, I hit escape. I don't know why. See if I can remember. So when you mix up stuff, when you mix up the wrong stuff, he's lucky. This stuff is still moving. And a lot of this stuff will not move. So let me see. There it is. So what he's lucky, he can actually keep this stuff moving to empty out his tank. But if you're like the other guy with 2,4-D and stuff, so, you know, this is part of the incompatibility of products. And again, go back to the label to see what was done. And I guess I learned a couple things from Bill, and to see when they read that, if you read the label, did it tell you not to mix with something? But if you did mix it, to what, Bill, increase the rates, that would be chemical, or to see if there's another warning, add an adjuvant or whatever, or a compatibility agent, or yeah. All right. So again, if you're using dry products and you're putting in with a lot of fertilizer, I'd rather see you pre-slurry the dry stuff in a bucket, get it mixed up in water, and then add that to your tank, because there's not going to be any water. And I think what I'm going to do, Stephanie, is finish this section. We're not too far in, and then we'll take us a break.
Sounds great.
Agitation is a big one. And so what I want to do, you can see the oils here. This one is soluble because I can see through it. You can see this concentrate in the bottom. I gotta agitate it. And these are the products that I have to agitate. And what I want to end up with are products that look like this. Now, what I found out recently is if the agitation is too strong, it screws up some of the chemistries. So again, some inerts are separated. Some anti-drift agents can break apart. And then some of these capsules can also break apart. So I don't have a documentation to tell you when it's too much. I'm just going to show you something. Do you believe, and I hope you would say, Stephanie, that that's not very much agitation? So this was a forestry guy, and I said, man, give me some agitation. He says, I can't. That's all I got. I said, stop. You're hurting my ears with the noise. Just drive on the road and shake it up. That's better than what we're doing here. Do you see this as being pretty good agitation? In my mind, this is pretty good. Here is another one that's pretty good. by moving things around. What I want to show you is when something is too much. That is too much. And this was real. I asked the guy, are we going to cook donuts or fried chicken here? What are we making? Because I hope it's not your chemistry that we're going to try to mix in here. And I have to tell you, my mindset before I worked on this was exactly this. The more agitation, the better I can mix it up. But really what I learned was too much screws up some of the chemicals, which could impact what we do. Cold water slows down. Bill, you and your student did a study on this years ago, and I think you found that cold water, not hot water, warm water, cold water in the early spring that sits out in the tanks, and cold water in the late in the fall that sits out in the tank takes the temperature of what the air temperature is, right? And you found,
Yes. Yep.
Well, I hope I'm saying it right. In some cases, some herbicides were less effective on specific species. Is that right? Did I say it right?
That's correct. Yeah.
So would you expect, if I'm terminating in the early spring, and I think you said, Stephanie, did you say, well, what's the date, or Tony, what is a date, or Hans, what's a date you would like for me? And it depends on the area of the state, but give me what would be a good date, a good month to be considering it.
End of April.
So at the end of April, would you expect to have some temperatures in the 40s? Low temperatures.
Yes.
There's a good chance of that, yes.
Yes. And so if I went out and pulled water out of a tank in early spring to terminate the cover crop, and it was cold water, let's say, Bill, I'm making it up, 45, would you expect that Roundup to be less effective on some of the weeds? And I'm not sure I'm asking the right question.
Yeah, absolutely. I mean, by the time you figure either the tender truck or the sprayer got to the field with a tank full of spray, it's going to be whatever the air temperature is. So if you're in that 40-degree temperature range, it's too, it's really colder than what we'd like to see a spray from the standpoint of plant health. So even if you could get the water temperature heated up to say 60 or 70 degrees, you still have plants growing in those cold weather. So there's likely two things going on there. Cold, less lower solubility of the herbicide in the spray water, and then the plant's not actively growing as well.
So there's that double combination that kills these chemistries, makes them less effective. Yes. I would rather, Bill, if I was, and again, I'm making this up as we go, I would rather do the termination using water out of a well. That's about, at least that gets me to 55 degrees plus or minus, than to use something that's outside if I'm going to terminate to try to get, but again, I've got a double problems on the water and the plant. I thought I would show you this one here just to show you not only is the water temperature, and Bill talked about cold water can hold less material. I think he said solubility. That's why he's a full professor and I'm not. But if you looked at the water temperature, look at the sugar cube on the left at 40 degrees and look at the sugar cube at 80 degrees, and you can see the 80 is already gone. So it also means that if I'm out in early season, I need to really pound this stuff in, Bill. It's going to take me a long time to get this stuff to blend into the water, right? It's
yes, and that's where, so for the if there are farmers mixing in the field, if I recall correctly, there's a lot of labels that will say agitate for a minimum of 10 minutes. And that's hard to do when you're busy, but this is where, maybe when it's cold like that, you have a tender truck bring a hot load to the field because at least it's been agitated for however long the time has elapsed since it was dumped into the tank till it was delivered to the field.
And so, Bill, that's a good point. If I looked at this sugar cube here, and I'm spraying this, and this as far as I got, I've only got part of my chemical into the water. The rest of it's sitting at the bottom or floating. It's sitting at the bottom or wherever it's at, but it's not in solution and it's not in suspension. And so I had this one, Bill. A guy sent me, one of the reviewers of the publication said that's how long it takes him to dissolve ammonium sulfate into cold water. And this was 4-degree water coming out of a water tank that's sitting outside. And that's your point.
Right off the top of the head, I can think of 3 active ingredients that are hard to get into solution in cold weather conditions. Because we'll run into tank contamination sample, or not tank contamination, but herbicide injury, and also some tank contamination samples that will come into the clinic. So anything with atrazine in it, so whether it's atrazine alone or an atrazine premix, is really slow to go into solution. Anything with Valor in it and anything with Authority in it. So you've got 1 corn herbicide and 2 soybean herbicides that can be problematic as far as getting them into solution, and cold water will just magnify that problem.
Okay. Now, if anybody has any questions, we're trying to cover lots of little topics. Some of this you already know, some of this you may not, but if you have questions, just ask us. Bottom line is, if you're dealing with somebody, you didn't get a good kill, you got to go back to that label and to try to figure out, are there any warnings? This is not a label, it's a sales sheet, but you can see what they've done here is given me compatible, incompatible. So here's one that this particular product is incompatible here. You'll see it on the label. Just take a look at that label if you're having problems of not getting killed beyond asking these very simple questions.